is. A global company with distributed development teams built a web application using a microservices architecture running on Amazon ECS. Each application service is independent and runs as a service in the ECS cluster. The container build files and source code reside in a private GitHub source code repository. Separate ECS clusters exist for development, testing, and production environments. Developers are required to push features to branches in the GitHub repository and then merge the changes into an environment-specific branch, development, test, or production. This merge needs to trigger an automated pipeline to run a build and a deployment to the appropriate ECS cluster. What should the DevOps engineer recommend as an automated solution to these requirements? A. Create an AWS CloudFormation stack for the ECS cluster and AWS code pipeline services. Store the container build files in an Amazon S3 bucket. Use a post-commit hook to trigger a CloudFormation stack update that deploys the ECS cluster. Add a task in the ECS cluster to build and push images to Amazon ECR, based on the container build files in S3. B. Create a separate pipeline in AWS code pipeline for each environment. Trigger each pipeline based on commits to the corresponding environment branch in GitHub. Add a build stage to launch AWS code build to create the container image from the build file and push it to Amazon ECR. Then add another stage to update the Amazon ECS task and service definitions in the appropriate cluster for that environment. C. Create a pipeline in AWS code pipeline. Configure it to be triggered by commits to the master branch in GitHub. Add a stage to use the git commit message to determine which environment the commit should be applied to. Then call the create image Amazon ECR command to build the image, passing it to the container build file. Then add a stage to update the ECS task and service definitions in the appropriate cluster for that environment. D. Create a new repository in AWS code commit. Configure a scheduled project in AWS code build to synchronize the GitHub repository to the new code commit repository. Create a separate pipeline for each environment triggered by changes to the code commit repository. Add a stage using AWS Lambda to build the container image and push to Amazon ECR. Then add another stage to update the ECS task and service definitions in the appropriate cluster for that environment. Correct answer is B. Next question is: for auditing, analytics, and troubleshooting purposes, a DevOps engineer for a data analytics application needs to collect all of the application and Linux system logs from the Amazon EC2 instances before termination. The company, on average, runs 10,000 instances in an auto-scaling group. The company requires the ability to quickly find logs based on instance IDs and date ranges. Which is the most cost-effective solution? A. Create an EC2 instance terminate lifecycle action on the group. Write a termination script for pushing logs into Amazon S3, and trigger an AWS Lambda function based on S3 put to create a catalog of log files in an Amazon DynamoDB table with the primary key being instance ID and sort key being instance termination date. B. Create an EC2 instance terminate lifecycle action on the group. Write a termination script for pushing logs into Amazon CloudWatch logs. Create a CloudWatch events rule to trigger an AWS Lambda function to create a catalog of log files in an Amazon DynamoDB table with the primary key being instance ID and sort key being instance termination date. C. Create an EC2 instance terminate lifecycle action on the group. Create an Amazon CloudWatch events rule based on it to trigger an AWS Lambda function for storing the logs in Amazon S3, and create a catalog of log files in an Amazon DynamoDB table with the primary key being instance ID and sort key being instance termination date. D. Create an EC2 instance terminate lifecycle action on the group. Push the logs into Amazon Kinesis Data Firehose, and select Amazon ES as the destination for providing storage and search capability. Correct answer is C. Next question is: a DevOps engineer manages a large commercial website that runs on Amazon EC2. The website uses Amazon Kinesis data streams to collect and process web logs. The engineer manages the Kinesis consumer application, which also runs on EC2. Spikes of data cause the Kinesis consumer application to fall behind, and the streams drop records before they can be processed. What is the fastest method to improve stream handling? A. Modify the Kinesis consumer application to store the logs durably in Amazon S3. Use Amazon EMR to process the data directly on S3 to derive customer insights and store the results in S3. B. Horizontally scale the Kinesis consumer application by adding more EC2 instances based on the Amazon CloudWatch metric. Increase the Kinesis data. Get record.iterator age milliseconds streams retention period. C. Convert the Kinesis consumer application to run as an AWS Lambda function. Configure the Kinesis data streams as the event source for the Lambda function to process the data streams. D. Increase the number of shards in the Kinesis data streams to increase the overall throughput so that the consumer processes data faster. Correct answer is B.